All right, let's do one more design question before I go to sleep today, 20th of August, 9 to 17th September. We're going to do serialize and deserialize the binary tree. So yeah, for we can't send a tree object over the internet. We can only send bits. Um, but what we can send over is a bunch of string. So let's find out a way that we can send over a string, like let's say over the internet, so that whoever receives this string can construct the binary tree. So in order to actually solve this question, we can have, this is a typical graph traversal question. So we'll be traversing the graph and then adding the properties to it. We can either use a DFS or a BFS. My first approach is going to be using a breadth first search. So we'll be using a DQ popping from the left, and then we'll be writing about it. So we'll do the serialized code for it first. So we'll go to, for each layer, I'm just going to say what it will look for each layer. So for the first layer, we'll queue this root layer, this root node, and then we'll pop it, and then it will see if it has a left node. If it does have a left node, yeah, if it does have a left node, we'll get the left, and then we'll do the root, and then we'll add a comma. And then we're going to add, well, since we're here, we're going to add it, and then we're going to add a comma to it. And then we're going to add the left, if it, yeah, so if we do have a node right now, we're going to add the left one and the right one. So we're going to go to the left here, we're going to add two, and then we're going to check, does it have a left and the right one? Well, no, since we are on a node, we're going to add the left and the right one to the queue. And then we're going to go here, it's none. So if it's none, we're going to simply add the words none to it. And then we're just gonna break out of it because there's no more children beneath that. For the same thing over here as well for two. And then how this will work is to go by layer through layer for the queue. So let's try to do the serialize. So we're gonna have a queue, it's gonna be DQ, and then we're gonna append this root node to it. We're actually gonna have an output array string as well because we'll be outputting a string. Now we're gonna iterate through while we have something in the queue. So while queue, we're gonna get our node. It's gonna be queue.popleft. Queue.popleft. Now we're going to check it. If not none, so if the node is literally none, well, this might happen, right? It could be none. If not node, so if the node is none, we're going to add the string of none and a comma, and then we're just going to break. We're going to continue to the next node because there's no point in adding the children for this. But if there is a node, we can simply add this node's value. We're going to add, maybe I'll do an f string. Should I do an f string? I'll do an f string. So whatever output is, and then we're going to add node.val, and then we're going to add a comma after that, node.val. And then after that, for the queue, we're going to append the left of this node and append the right of this node. We can always ensure that the left and right node will exist, even if it is none, because this node will always be, well, because a node will always be true. A node will always exist, because if it doesn't, it will simply continue. And in the end, we'll be able to return the output. So if we actually see the product of this, let's see what it is. Because whatever gets called here will be here. So 1, 2, 3, 1, 2, 3 by layer, 1, 2, 3, and then none, 4, 5, and then none, 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 none. Okay, good. So for our deserialized node, how are we going to do this? We can also use a BFS approach for this. So we'll first get the node, and then we'll populate that. And then we can see the next two values are tightly related to this node. So we'll add to this node, right? So for the left node, we'll do the left one first because the left one comes first, and then we'll add it as a left node, and then we'll add this node to the queue so that this one will be processed after our node has been finished. So we'll add this to the queue after, and then we'll do the right node and add that to the queue as well. And since that's a real node, we'll add that to the queue as well. And now we're going to do two. For two, we're going to be looking at none, and since it's none, this means that we don't have any nodes, we have any children for it, so we can simply skip over it. And then let's do its right one, it's none as well, so the right one means there's no nodes for it, so we can skip over that as well. And next in our queue, we have our 3 that we appended while we were processing 1, so we're going to pop the 3, and then we see we have 4, which returns to that child. So let's first do that. So first thing we have to do is going to split up our data. So split equals data.split. I'm pretty sure that's how you split. Python split string in by. Yeah. So that's what split looks like. And then we're gonna have a iterator. Oh, actually we're gonna have a, let's create our first root node. So our root node is gonna be a tree node. It's gonna have a value of the first in our split, which is gonna be 1 here. For here, actually we're gonna do this. If not root, we're gonna return an empty string, just an edge case that we have to cater for. And then we say we're gonna have another queue for this, where we have a dequeue, and then we're gonna append the root to this dequeue. So while the queue exists, we're gonna get it. So we're gonna pop it out. So node equals queue.pop, pop left. So we're gonna pop in from the left, which is gonna be our first node. Now I'm going to check it. If split does 1 is not equal to none, this means that we do have a node. Not 1, it's going to be I. This means we have to create a new node. So uh, new node equals tree node. And the value of this is going to be whatever we are at right now. And then for this one, we said it's going to be the left. So node.left equals new node. That should be it. So we're going to add 1. Now that we did the left one, we're going to now do the right one. Yeah, and if it is none, we'll just simply move over. Then we're just going to make sure that the right node is the new node. We're going to append this new node to our queue as well so that it can get processed correctly. And I just do it here each because I do override the names of the new nodes here. And then I'll return the head of our node, which is root. And if we run it, this index is out of range. Okay, I need to check. And I is smaller than the length of our split. Actually, this might have to be equal to smaller than. Okay. String index out of range. This is a problem with a empty node. It's going to return that. I guess I need to check it here. If not data, we're just going to return. What am I returning? Am I returning nothing? What am I returning? Okay, I'm not returning anything. Cool. Yeah, so yeah, that's our BFS approach to this question. What would a DFS look like? It would be the same. It would be a DFS would be a recursive function. Let's try. So we'll add this to so we'll have a recursive function. We're going to send in an empty string first, and then the node that we're in. And we're going to add that node's value to, if it's not none, we'll add the node's value to the string, and then go to the left. And then we'll recurse to the left first. And then after the left, we'll recurse to the right and keep on adding towards the string. I think that's what the answer looks like here. Yeah, so we'll send in the root and an empty string. If it's none, we'll just do none, and then we won't recurse anymore because there are no more children's after it, but the structure will look exactly the same as what we've done. And then for the deserialize, let's see what it looks like. They split it, and then they send through the list. So this is just a first check. If the first node is none, then we'll just pop l.pop. Yeah, it'll just pop and return none. That's the answer. The root is none, but if it does exist, I see. So we're going to pop the top and then send in the new list with the new pop so that 0 will always be at the start. So it'll process 1, and then there'll be the root. And then the left of it will be 2, but we'll pop the 1 and then send the 2 down, so that'll be the left. Right, and then the left. I'm just thinking if this works. Hold on. So I pop this. So I set it to this. I pop this, and then my root dot left is equal to dish. Wait, I'm just wondering. Wait, does this actually work? Wait. So split, and then so the root node is set to this. So I create a new root node, and then the left of this root node would be 2. I'm actually curious. If we pop it, so we're gonna pop 2, right? And then we're gonna send through this for the left node for the two's children, but the two's children is none. Right, let me ask ChatGPT. Maybe the serialized code is different. Maybe this is not. Maybe it's not like. Uh, let's see what that looks like. 1, 2. Okay, so it is different how they serialize in the first place. Okay. Of course, because it is a DFS. Yeah. No. Okay, yeah. I was gonna say with the way that we've done it, if we done the BFS here and then we try to deserialize using DFS, it's not gonna work because how we store the data is different. So they literally do, yeah. Well, this is a DFS by nature, right? 1, 2, and then it goes down for here, and then it goes to the 3, 4. Yeah. But for us, it's a BFS, so we do 1, 2, 3, and then none, 4, 5. So it's more of like a how it's preserved over here. I guess is this a in order is this an in order traversal? Let's see. No. In order traversal, so it's left to right. Yeah, so this looks like we go to the far left. No, we append it. Okay. It's just a top down. Yeah, but cool. So that's a serialized and deserialized binary tree.